So let's take a minute to understand why when you raise a complex number to a power in either polar or exponential form, so when you raise, this is not a complex number, this is just a monomial, to a power, that you raise the r value to the power and you multiply their angles. So when I do this algebra problem, the 2 has to be raised to the 4th power to become 16. But the x cubed, when I raise that to the 4th power, the shortcut is to take the 3 times the 4 and get 12. So the final answer to this problem is 16x to the 12th power. So likewise, if I had 2, an r value of 2, e to the 3j, the angle being 3, and I wanted to raise that to the 4th power, I would take the r value and raise it to the 4th power. But I would take the 3 in the 3j, and I would multiply that by the exponent of 4, and that would become 12j. So again, I'd have 16e to the 12j power. So I'm multiplying the angle by the exponent. So remember, the only difference between exponential and polar form is that this one's in degrees and this one's in radians. So when I'm taking, when I'm completing this process, I'm going to raise the r value to the power, but I'm going to multiply the angle. I'm going to just put an abbreviation by the exponent. So when I do this one down below, and I might put this on my note card again, when I raise a complex number to a power, I raise the r value to a power, and I multiply the angle by the exponent. I multiply the angle by the exponent. So I'm going to raise 3 to the 4th power, but I'm going to multiply the 120 degrees by the exponent. So I know that 3 to the 4th is 81, and then 120 degrees times 4 is 480 degrees. And don't forget, you really should reduce that to 81 at an angle of 120 degrees, because if you subtract a full circle from 480, you're going to get the 120. The next problem, not so easy, to raise a complex number in rectangular form to a power. And as a matter of fact, when you see this one on the test, there are going to be a number of you who might write, I hope not, who might write this out 8 times and try to FOIL this. And you want to talk about a nightmare in the happenings, in the way, because there's likely going to be a sign mistake made. I hope you're laughing right now, because I don't even know if I've written this 8 times yet. 1, 2, 3, 4, 5, 6, 7, 8. And sure, I could do those 2, and whatever that answer would be this answer, and whatever this answer, and whatever. But it is just so much easier when a complex number is in a rectangular form, and I want to raise it to a power, to think about it in polar form. So think about this minus 1 from the origin. Go to the left 1 and then go down 1j. And think about this as a vector. So remember, the right triangle here is going to have a -1 here and a -1 here. And when you put that into the Pythagorean theorem, the -1 squared is a +1, and a -1 squared is a +1, and 1 plus 1 is 2, square root of 2. So the r value for this one is the square root of 2. And the angle theta is found by taking the inverse tangent of 1 divided by 1. I hope you can look at that and see that that's a 45-degree angle. But remember, that's a reference angle. This right here is 45 degrees. So from the x-axis, it's 180 plus 45 degrees, because I'm in the 3rd quadrant. 180 degrees plus 45, or 225 degrees. Now I'm ready to take the square root of 2, which is at an angle of 225 degrees, and I'm ready to raise that to the 8th power. So I have to take the square root of 2, and I have to raise it to the 8th power. And remember, I have to take the angle and multiply it by the exponent. Well, that angle is huge. I think it's 1800 degrees. The reason I use the square root of 2 here instead of 1.414 is because if you take your calculator right now and go second square root of 2 and close the parentheses, And it probably would have been good if you'd put open parentheses to begin with and close them right here, and then go caret 8. That's going to give you exactly the square root of 2 times the square root of 2 times the square root of 2 times the square root of 2 8 times. And I just want you to know square root of 2 times square root of 2 is 2. And you do it 2 more times and it's another 2, and you do it 2 more times and it's another 2, and 2 more times and it's another 2, and 2 times 2 times 2 times 2 is 16. So the square root of 2 to the 8th power, if you use that exactly, you'll get 16. If you use 1.414 to the 8th power, you'll get 15.99999. So this is an exact answer. Finally, by the time you subtract 360, and subtract 360, and subtract 360. It does happen that 360 goes into 1800 5 times, I think. But anyway, when you subtract it enough times, you're going to get down to 0 degrees. So the answer to this problem is 16 at 0 degrees. In rectangular form, that means 16 times the cosine of 0 plus j times the sine of 0. And if you were to type that, 16 times the cosine of 0 is just the real number 16, and 16 times the sine of 0 is nothing. So as a complex number in rectangular form, it'd be 16, period. You could write the 0j, but that's, nothing. But that would be a way to see it in the form that was given. Okay, so let's now talk about adding and subtracting complex numbers in polar form. So first of all, just want you to know that when we added and subtracted before in rectangular form, this was really simple. So if I was taking these two complex numbers and subtracting them, I would just take the 2 plus the 5j. And if I wanted to subtract a negative 3, I would add 3. And subtract 9j, I put a minus 9j. And the real parts add to be 2 plus 3 is 5. And then 5j minus 9j is a minus 4j. And that's it. I'd be done. You got to be careful here. These are vectors. These have direction. They're not going in the same direction. Like the real parts either are going to the right or going to the left. At least they're opposites. This one at 142 degrees is over here in the second quadrant. And this one at 71 degrees is something like that. So you can't be subtracting these when they have angles. So you have to take the 15.9 and you've got to multiply it by the cosine of 142.6 degrees. And then you've got to take it again and multiply it by the sine of 142.6 degrees. So when you distribute this, this one turns out to be a negative 12.6 for the real number and 9.6j for the imaginary number. Well, that makes sense because that's in the second quadrant. So it's got a negative x and a positive y. When you do the same thing with this one, so 18.5 times the cosine of 71, this is 71 degrees, so these should both be positive. That you'll get 5.9. And when you take 18.5 times the sine of 71, you'll get 17.5j. Don't forget, this was a subtraction problem. Hopefully you didn't mind that I didn't write this out. I might go ahead and do it. So what I did just now is I took 18.5 times the cosine of 71.4, 71.4 degrees, and then I took 18.5 times the sine of 71.4 degrees to get this rectangular form. Don't forget, you got to subtract, so this has got to become a minus 5.9, and this has got to become a minus 17.5j. So I'm going to recopy this first complex numbers values down. So the real parts, the negative 12 and almost a negative 6, add to be about a negative 18.5. And this positive 9.6j and take away 17.5j turns out to be a minus 7.9j. Now, this problem was given in polar form, and when we do our lab project, given in polar form, I'm going to ask you to get it back into polar form when you're done. So this is the answer to the subtraction of these two problems, but it's in rectangular form. So if I were to draw a picture of where this answer is It's very much so in the third quadrant. So I go to the left 18 and down 7, and I have the vector that I'm speaking about. So I'm going to go ahead and let the computer have adapted for me. So this is the negative 18.5. This is the negative 7.9. When you put that into the Pythagorean theorem, please, you would get an R value of 20.1. You can use your program, but if you do it by hand, just don't bother with these negative signs, because when you square these numbers, it'll turn out to be positive. Your reference angle would be by taking the inverse tangent of the 7.9 divided by the 18.5 would be 23.1 degrees. And then because these two are both negative, you know you're in the third quadrant, or you can see it from your picture. So you can go 180 degrees plus these 23.1 degrees. So I think that's going to be 203.1 degrees. So your angle is 203.1 degrees, and your R value is 20.1. And this is the answer to this problem in polar form. Remember, this is rectangular form, but the problem was given in polar. Would you pause the video and would you do the next one? I'm just going to write the answers for this next one. Okay, the answer for this next one, I'm just going to real quick write down the 239.7 minus the 158.7j is this one's rectangular pieces. This one is a negative 7.1 and 625.4j. When you combine all those, the real parts turn out, remember it's a subtraction problem, so you're subtracting all of this. This turns out to be 309.8 minus 784.1j. When you use the Pythagorean theorem on this, the R value turns out to be 843.1. Your reference angle is 68.4 degrees for these two x and y values, but because x is positive and y is negative, you're in the fourth quadrant, and that would be 360 minus the 68.4, which is 291.6 degrees. So 843.1 at an angle of 291.6 degrees.